All right, before we learned the sum and difference formulas for sine, cosine, and tangent, so we're going to do some applications now of those formulas. Not too bad, you have to follow the formulas, have them written down in front of you, and then just kind of work through it. So let's see what's going on with this. Cosine of arctan of 1 plus arc cosine of x. So I'm seeing of cosine of something plus something. So I'm seeing of course, the sum and difference formulas. All right, so I'm going to use some different colors here to illustrate something. So let's say we're going to call this U plus, let's call this one V. And let's go through this. So the cosine U plus V, cosine U cosine V minus sine U sine V. So let's write that out. Cosine U cosine V minus sine U sine V. Okay. And we're going to say that U is equal to arc tan of 1 and V is equal to arc cosine of x. Okay. So we use the formula. We kind of figured out what U and V are, but we need to write it out as an algebraic expression. So we want to get rid of all this trig stuff. And we can do that. What we're going to do is we're going to take these two expressions right here. And remember, arctan, so this is the arctan of this ratio equals this angle. So U and V both represent angle values. What we have to do is write out those angle values as a expression. So I'm going to make triangle U. Actually, I'm going to rewrite this. So U equals arctan of 1 means the tangent of U is equal to 1 over 1. So let's make a triangle out of that. So here's angle U, and this is opposite over adjacent, so it's 1, 1. And if we set this up, that's 1, 1, and this would be square root of 2. So I used that information and I created a triangle from that. All right, same thing with this one now. V equals arc cosine of x means that cosine of V equals x over 1. Remember, whenever I'm looking at these ratios, I want to see them as a ratio, so I put them over 1. So this triangle would end up being, doesn't have to be drawn to scale or anything, so angle V, cosine is adjacent over hypotenuse, so the adjacent side is x. The hypotenuse is 1, and if I do a Pythagorean theorem, it's going to be the square root of 1 minus x squared. Okay? All right, so now we can actually do this. We can actually figure these out now. So, what is the cosine of angle U? Well, here's angle U. The cosine is adjacent over hypotenuse. So cosine of angle U is 1 over square root 2. Cosine of angle V, we actually already know that. That's just going to be x. Minus sine of angle U, that's opposite over hypotenuse, so 1 over square root 2. And sine of angle V, opposite over hypotenuse, so the square root of 1 minus x squared over 1. So we've gotten rid of the trig. We now have it written algebraically, and all we have to do is kind of make this a little bit neater. I see this as two terms, something minus something, and they both have 1 over the square root of 2, so I'm actually going to pull that out front. 1 over square root 2, leaving behind x minus square root of 1 minus x squared, x minus square root of 1 minus x squared. And now I can just kind of write it out a little bit nicer. We can, keep in mind, when you see the answers in the back of the book, yours might not be exactly the same, but just know enough. First off, if you're not sure if it's the same and you want to ask, you can ask me and I will verify whether it is the same or it is not. Um, but don't think that you're automatically wrong. That's what I'm getting at. So, this is the answer, but this is one version of the answer. You could have actually rationalized the denominator and gone further, but we're going to leave it in this form right now. So this algebraic expression does represent this trigonomic expression. They are equivalent expressions. All right, so that's a little bit different, but it's not so much. I mean, there's the trig involved there, but a lot of this is your practice in algebra. I mean, you would be amazed at how much algebra is used. Well, maybe you wouldn't be amazed, but there's a lot of algebra used in calculus, and just from teaching calculus. It's not the calculus that gives the kids problems, it is the algebra that is used in the calculus. So, um, doing something like this isn't that common, but the algebraic process involved is very, very beneficial to you. Okay, the other thing we're going to do today is we're going to prove an identity. So prove that cosine of pi over 2 minus x equals sine of x. Okay, so using our new formula, can we prove that this is true? Just like any of our other properties that we've been using, we could do this. So we're going to use the difference formula for the cosine, which will be cosine u cosine v plus sine u sine v. So let's write that out and see what happens. And let's see if we can make it equal to sine x. So cosine pi over 2 cosine x plus sine pi over 2 sine of x. And let's see what happens. Let's see if anything cancels. Let's see what we can do with this. Well, cosine pi over 2 is 0. So I can actually simplify that because that's the cosine of a ratio. Cosine x, I can't do anything because I don't know what x is yet. Sine of pi over 2, that's another ratio. Sine of pi over 2 is 1, if you look at the graph or your unit circle. Sine of x, once again, we don't know what x is, so we can't do much with that, equals sine x. And what happens? Well, 0 times anything is 0. That part's gone. And then 1 times anything it's an identity. So here we have sine x equals sine x. So you can actually prove these identities just like we did with the other formulas. It might take a little bit more time, and if you get stuck on them, just ask me. Like, show me what you've done so far, and I can kind of push you to the next step, and you might be able to figure it out yourself. Anyhow, I have a few examples of these on page 384. I would like you to try 51 and 53, which are like the first example I just showed you, and then 57, 59, and 61, which are properties like this, where you're going to prove something. So you want to make one side equal to the other side. All right, let me know if you get stuck on any of them. We can walk through them. Speaking of getting stuck, I have been very happy, you guys that have been asking me questions. Hopefully my answers are good enough. I can work through a whole problem with you, but I'd rather just kind of nudge you to the next step. It seems to be working well so far. Let me know if you need any help, and we can work on it. All right.